All right, folks. We are in section 1.1 here. We kind of worked through this in class today. If you were not in class or need a quick refresher, that is what this video would serve for. So we began class talking about the fact that we'd be solving linear equations in one step for the most part. And as we work through this, we have to make sure that we consider what we're being asked to find. And a lot of the times, and many times we discussed in class, we are searching for the variable and the value of that variable. And a lot of the times, x is the variable that we use. In solving these various types of equations, we'll be using these these properties. We have the addition property of equality, subtraction property, division, and multiplication property of equality. Again, we end up using the inverse operation in order to isolate the variables. So we worked through some of these questions in class, and I'm going to do a couple here. Hopefully this will help you out. I don't anticipate many issues. In solving this here, we see x minus 3 equals -5. That means I'm going to add 3 to both sides in order to get x being -2. So I use the inverse operation of subtraction, so I utilize addition. I'm going to jump to number 3. We see a question here, working with some fractions. We can use that ABC button on our calculator or our past knowledge of working with fractions. But we see g minus the third equals -2/3. I added a third to both sides. Ultimately, I get g equals -1/3 as a result. In question here, let's go with number 4. We talked about this in class, but that negative sign out front, sometimes a little bit challenging. What that means is you basically have one negative. You can put it up top in the numerator or in the denominator. A lot of times I find that if we can take that negative and put it into your denominator, it will clear the fastest. So as I drop that negative with the 5, I can then just simply multiply both sides by -5, because what I see is division, so my inverse is multiplication. So I'd be performing -3 times -5, get -15. And lastly, I know it looks a bit challenging, but number 6, we have this instance of pi involved. Not to worry, pi is an irrational number. It's has a notation that's very popular, but we still need to isolate x. This is still our goal, getting that by itself. So what I would do is let's clear the pi on both sides by just simply dividing by pi, and pi cancels, and all we're left with is x equals -2. All right. And from there, we proceeded to talk about working with types of story problems, right? Problem solving techniques. We talked about some buzzwords in class today. I'll review a few of them here. We had the word is we mentioned that referred to equals. We had the word of that referred to multiply. We had the word quotient. That's that strange one we've had for a while now, but quotient means division. Sum isn't a commonly used buzzword. Some references addition, and the word difference is what is typically utilized for subtraction. So we'll see that in a couple of these story problems here. Let's go ahead and jump into number 8 as I bounce around a little bit. But in 8, it says you're shopping online, you find a skateboard, costs $124.99. $42.50. It's $42.50 less than the price at a local store. So we're trying to find, it says write and solve the equation to find the local price. So our unknown, our x, is the price at the local store. So what I have is I have $124.99 equals, because that comes from the word is. So I just did $124.99, then the buzzword is, so I wrote the equal sign, $42.50 less than the price at the local store. Well, the price at the local store was defined as X. So minus $42.50 represents $42.50 less. So I have my equation, and I solve the one-step equation like I did all the computation questions we began with here. And as I add those to both sides, that will give me the value for X. So I have $167.49 is the price at the local store. This kind of summarizes the stuff we worked on in section 1.1 today and on Friday. Hopefully this helps you out, and I look forward to our next section together. Have a great night. Talk to y'all soon.